Hello there, and welcome to the Sleepy Science Channel. I'm so glad you found your way here tonight. Maybe it's been a long day, or maybe you're someone who likes to drift to sleep with quiet wonder, letting thoughts of distant worlds replace the noise of daily life. There's nothing you need to do now but rest. Let your mind grow still, your breathing slow, and your body light. Because tonight, we're not just closing our eyes, we're traveling through the realm of the universe's largest and most luminous stars, the titans of light. The sun so vast, their warmth could swallow our entire solar system. From the dark nurseries where they're born, to the radiant lives they lead, and finally, to the magnificent ways they end, scattering gold, iron, and stardust through the cosmos. We'll explore 100 sleepy facts to help you relax, unwind, and dream of the infinite. And if these calm explorations help you rest, consider liking and subscribing. It helps other sleepy travelers find their way here too. Now, close your eyes, and let's begin our quiet journey among the giants. Fact 1. The Nursery of Giants. Long before the first starlight shimmered, the universe was filled with quiet clouds of gas and dust, enormous, drifting seas of hydrogen, cold and slow, waiting for something to stir. Within these clouds, tiny ripples of gravity began to pull matter together, forming knots in the cosmic mist. These knots grew heavier, denser, and warmer with each passing eon, like the first sparks beneath a blanket of fog. In these invisible cradles, the stellar nurseries, the biggest stars begin their brief but brilliant lives. Some clouds are so vast they could birth thousands of suns. Others, like dark wombs of creation, glow faintly at their edges as new light begins to whisper from within. And somewhere in that soft darkness, a future giant takes its first breath. Beyond that breath, gravity grows stronger still. Fact 2. Gravity's gentle hand. It's gravity that decides which stars will become giants and which will remain small. Every atom of hydrogen, every drifting grain of dust feels the faint, insistent pull toward the center. The more that gathers, the stronger the pull becomes, a slow crescendo of invisible force. In the heart of a forming star, gravity presses so tightly that atoms fuse together, releasing warmth and light. For the largest stars, this collapse is enormous. Temperatures rise to millions of degrees, and the pressure builds until space itself seems to hum. The cloud brightens, its darkness dissolving into pale blue fire. Gravity, though fierce, is patient. It shapes the star not with chaos, but with rhythm. A slow tightening, a tender insistence that turns emptiness into radiance. And when the light finally breaks free, the cosmos awakens. Fact 3. The spark of fusion. Deep inside the newborn star, the first fusion reactions begin. Hydrogen, atoms merging into helium, releasing floods of energy that push back against gravity's grasp. This balance between the inward pull and the outward glow is what keeps a star alive. For the biggest stars, this spark is almost too bright to endure. Their cores burn with such intensity that time itself seems to race. Millions of years pass in what smaller stars would take billions to live through. From the outside, the light shines fierce and pure, a beacon against the black. But within, it's a quiet equilibrium, a harmony of pressure and light. The universe, for the first time, has a steady heartbeat, and it glows. Beyond that glow, the story of these giants only grows more wondrous still. Fact 4. When size becomes power. Among all the newborn suns, only a few grow enormous enough to become true giants. Their masses swell dozens, even hundreds of times beyond that of our own sun. And with such mass comes immense pressure, the kind that turns matter into fire and floods the darkness with brilliance. A large star lives fast, its energy burning like an endless storm of light. The more massive it is, the more furiously it shines, devouring its fuel in the cosmic equivalent of a single glorious breath. If the sun were a candle, these stars are roaring furnaces, illuminating whole regions of space. But even in their strength, there is fragility. Their brightness is both their power and their doom. For the more fiercely they burn, the sooner they fade. And yet, before that end, they sculpt galaxies with their light. Fact 5. The Eddington Limit. There's a quiet rule written into the physics of every star, a delicate balance between gravity's pull and light's gentle push. This rule is called the Eddington Limit. It defines how luminous a star can become before its own light begins to blow itself apart. When a star's radiation grows too intense, the outward pressure of its photons pushes against the gas trying to fall inward. For the most massive stars, that pressure can lift whole layers of matter into space, as if the star were slowly exhaling. The Eddington Limit is a reminder that even brilliance must yield to balance. Too much light, and the very force that creates beauty becomes the cause of loss. So the great stars live poised on the edge, bright enough to dazzle, but always in danger of their own light. Beyond this balance, vast clouds still wait to cradle new suns. Fact 6. Cosmic cradles. Across the sky, the nurseries of massive stars shimmer like distant jewels. The Carina Nebula, the Eagle, the Tarantula, each one a storm of creation where gravity and radiation dance together. Within these clouds, knots of gas collapse, forming young stars that flicker like embers behind veils of dust. The largest among them carve their surroundings with light, shaping pillars and caverns of gas that glow in soft reds and blues. These glowing sculptures are the universe's art, nebulae painted by the breath of newborn giants. Inside these glowing clouds, time feels slower. Stars are still learning to shine, and space hums softly with their awakening. Beyond the mist, rotation begins its quiet work. Fact 7. The role of rotation. Every star spins. Some turn slowly, like great drowsy wheels of light, while others whirl at astonishing speed. Rotation shapes the destiny of a star. It stirs its gases, mixes its layers, and guides how it shines. In the biggest stars, rotation can be so swift that their equators bulge outward, flattening them slightly like glowing discs in motion. This spin helps circulate heat and elements from deep within the core to the outer layers. It's a kind of cosmic stirring, keeping the star's fire even and alive. And when such a star nears its end, its spin can influence everything that follows, how it explodes, what it becomes, and what gifts it leaves behind. Through motion, the star remembers it is alive. And from that motion, great winds begin to rise. Fact 8. Winds that sculpt the sky. The largest stars breathe in gusts of light. They send streams of charged particles flowing outward. Stellar winds so strong, they shape the very clouds around them. These winds carry away the star's outer layers, forming shells, arcs, and delicate waves of glowing dust. Sometimes these winds collide with nearby gas, igniting it into brilliant curtains of color. Other times, they hollow out vast cavities, like cosmic bubbles expanding through the nebulae. The result is a sky shaped not by silence, but by breath, the gentle, continuous sigh of the universe itself. Though we cannot feel it, these winds whisper across light years, scattering the ingredients for new stars and planets yet to come. And within the glow of those winds, light reveals its true colors. Fact 9. Color and temperature. The color of a star is its signature, a reflection of its inner fire. The largest stars shine blue-white, burning at tens of thousands of degrees. Cooler giants glow in soft crimson, their light gentle and deep. The hue of starlight tells us everything: how hot it burns, how fast it lives, how soon it will fade. To our eyes, blue stars shimmer like ice, but their heat is fierce enough to strip atoms bare. Red supergiants, meanwhile, pulse slowly, their surfaces cool and vast, as though they are sighing through time. In every shade of light, the universe speaks softly, in colors that tell stories older than words. Beyond those colors, brightness begins to grow beyond comprehension. Fact 10. The scale of light. If you could gather the light of our sun and set it beside a true giant, the difference would feel impossible to grasp. Some massive stars shine millions of times brighter than our own. Their radiance floods the darkness, lighting entire regions of the galaxy. Yet brightness, in space, is not what it seems. From far away, even these titans appear as gentle glimmers. Their brilliance is softened by distance and dust, their power turned to shimmer. But up close, their light is a living sea, fierce, steady, and eternal in its flow. Astronomers measure this strength in luminosities, a quiet comparison that tells of unimaginable heat and distance. Each ray of light, born in the furnace of fusion, travels endlessly outward, a whisper of energy crossing time. Beyond that sea of light, we begin to recognize names, familiar beacons in the night. Fact 11. Meet Betelgeuse. In the shoulder of Orion glows a red supergiant called Betelgeuse, a star so large that if placed where our sun is, its edge would reach beyond Jupiter. Its light, a warm and flickering orange, is the color of fading embers. Betelgeuse lives in its twilight, nearing the end of its life as its core grows restless. Its brightness changes gently over time, pulsing like a slow heartbeat in the winter sky. Ancient eyes once watched it rise and set, weaving myths of warriors and hunters around its glow. Even now, astronomers wait and wonder, for one day Betelgeuse will end in a grand supernova, a final, breathtaking bloom of light. Until then, it watches over us, patient and magnificent, a reminder that endings can be beautiful too. Beyond Orion's shoulder, another ruby star burns softly against the dark. Fact 12. Antares, the heart of Scorpius. Far to the south, in the constellation of Scorpius, lies Antares, the beating heart of the scorpion. Its name means rival of Mars, for its red hue mirrors the planet's glow. But Antares is far larger, far older, and far more distant. A red supergiant so vast it could engulf the orbit of Earth many times over. Through a telescope, it appears as a soft ember surrounded by faint gas, the remnants of its own stellar winds drifting away. In ancient times, sailors and poets marked it as a symbol of passion, fire, and change. Antares is the calm heart of a cosmic creature pulsing gently in the Milky Way's dust. And just beyond it, a blue light gleams, a star of ice and fire, waiting to be seen. Fact 13. Rigel's sapphire flame. In the foot of Orion burns Rigel, a blue-white supergiant whose light cuts clean through the winter sky. Where Betelgeuse glows softly red, Rigel blazes like a shard of frozen sunlight, hot, pure, and radiant. It burns at nearly 12 times the sun's mass and tens of thousands of degrees. a storm of energy shimmering across space. Though it appears steady to our eyes, Rigel's brightness is a tide, ebbing and flowing through subtle cycles. Around it, a faint cloud of reflection nebulae glimmers, dust illuminated by its relentless shine. Rigel reminds us that cold colors can still hold warmth, that serenity can come from the most intense fire. Beyond that sapphire glow lies another, gentler beacon, one that guides us across immense distance. Fact 14. Deneb, the distant swan. High in the summer sky, at the tail of the constellation Cygnus, shines Deneb, a supergiant so far away that its light takes thousands of years to reach us. Yet even across that gulf, it remains visible to the naked eye. Such is its power, a single star outshining entire clusters. Deneb is part of the Summer Triangle, a celestial landmark that has guided travelers for centuries. Its light is ancient. The glow we see tonight began its journey long before human history was written. Through telescopes, Deneb reveals a delicate blue hue, soft and ghostly, like moonlight scattered in mist. It's a reminder that even the farthest light still finds its way to us, quietly crossing the dark. And further still, there waits a star so large it challenges every definition of size. Fact 15. VY Canis Majoris. Hidden deep in the southern constellation of the Great Dog is VY Canis Majoris, one of the largest stars ever known. If it replaced our Sun, its swollen surface would extend past Saturn's orbit. This red hypergiant is old and unstable, shedding vast shells of gas and dust as it nears the end of its life. Through space telescopes, it appears wrapped in swirling layers, a hazy cocoon glowing faintly in infrared light. Each layer marks a breath, a sigh of a star too vast to contain itself. Though it flickers faintly from Earth, in truth, it burns with unimaginable power, a dying ember the size of a solar system. And beyond its drifting dust, another crimson light beckons, a star once called the Garnet of Heaven. Fact 16. Mu Cephei, the Garnet Star. In the constellation Cepheus, glowing deep within the northern sky, lies Mu Cephei, the Garnet Star. William Herschel once gave it that name for its rich, royal hue, a red so deep it seems to shimmer with velvet warmth. Mu Cephei is a red supergiant, among the largest and most luminous visible to the naked eye. Through a telescope, its light feels almost tangible, soft, wine-colored, and patient. Its immense body swells and contracts over long seasons, changing brightness ever so slightly. The glow that reaches us tonight began its journey centuries ago, carrying the quiet pulse of a star nearing the end of its life. To look at it is to see serenity itself, a light fading beautifully, not in fear, but in peace. Beyond that regal glow, another giant waits in silence, even greater still. Fact 17. UY Scudi's vastness. Y Scudi is a name that sounds almost modest for such an extraordinary star. Hidden near the constellation Scutum, this red hypergiant is one of the largest ever measured. If it sat at the center of our solar system, its surface would reach far beyond Jupiter, perhaps even brushing Saturn's path. Despite its unimaginable size, UY Scudi's light is soft and steady. It flickers gently as its layers rise and fall, slow, rhythmic waves in a sea of fire. Around it, thin veils of dust drift like smoke, remnants of matter breathed away into the void. Astronomers describe it not just in numbers, but in awe. To them, it's a quiet cathedral of gas and heat, vast, impermanent, and endlessly beautiful. And beyond even UY Scudi's reach, there are stars that hide behind veils of dust, known only to infrared eyes. Fact 18. Westerlund 126. Deep within the star cluster. Westerlund 1 lies one of the universe's great hidden giants, Westerlund 1 in 26. It dwells in a region thick with dust, invisible to ordinary sight, yet glowing brilliantly in infrared. This red supergiant is a mystery, a ghost wrapped in its own fading breath. Its light scatters through the cluster, illuminating younger suns being born nearby. The gases it releases form glowing tendrils, trails of its final exhalations. Few stars remind us so clearly that endings can nurture beginnings. Even as it dissolves into space, Westerlund 126 gives life to future generations of light. And beyond that shrouded cluster lies a storm of brilliance, a pair of stars that once shook the sky itself. Fact 19. Eta Carinae's Wrath. In the southern skies, veiled within the Carina Nebula, dwells one of the most dramatic stars ever known, Eta Carinae. It isn't a single star, but a pair. Two giants locked in a volatile dance. One of them, perhaps 100 times the mass of our Sun, burns with ferocity beyond comprehension. In the 19th century, Eta Carinae erupted in what astronomers call the Great Outburst, an explosion so vast it briefly became the second brightest star in the night sky. The blast ejected a cloud of glowing gas shaped like twin lobes, now known as the Homunculus Nebula. Even today, that nebula expands silently, lit from within by the restless stars that created it. Eta Carinae reminds us that even chaos can be luminous. Beyond that storm of light, another contender for the crown of brightness waits quietly. Fact 20. R136A1. At the heart of the Tarantula Nebula, in a distant corner of the large Magellanic Cloud, burns R136A1, a star so massive that it may be the heaviest ever observed. Over 200 times the mass of our Sun, it radiates nearly 10 million times more light. Its surface burns hotter than any known furnace, and its radiation sculpts the surrounding nebula into waves and pillars. From Earth, we cannot see it without powerful telescopes, yet its presence is felt across space. R136A1 lives quickly. Such power cannot last long. It is not simply a star. It is a brief, brilliant experiment of nature, testing the limits of what creation can sustain. And to measure such greatness, we must learn to use light itself as our ruler. Fact 21. Light as a ruler. In the vastness of space, distance cannot be measured by steps or by ropes, only by light. Astronomers read brightness like poetry, using its faint changes to judge how far away a star might be. A star's light fades with distance, following laws as soft and certain as the tides. By comparing how bright a star appears to how bright it truly is, scientists can calculate the span of space between. It's a simple idea, yet it has mapped entire galaxies. Every glimmer we see carries a story of distance, time, and patience, a silent journey written in photons. And beyond those measurements, another delicate method waits: the wobble of the stars themselves. Fact 22. The power of parallax. When you hold a finger before your eyes and shift your gaze, it seems to move, a tiny illusion caused by perspective. Astronomers use this same effect, called parallax, to measure the heavens. As Earth orbits the Sun, nearby stars appear to shift slightly against the distant background, tracing out invisible triangles across space. By studying that motion, so small it could fit within a whisper of an angle, scientists can determine how far away a star truly lies. The closer the star, the larger its gentle wobble. It's a method that feels almost tender, as if the universe itself leans a little closer when we look at it from two sides. Beyond that subtle dance, we listen to light itself for more secrets. Fact 23. Spectral signatures. Every star sings a quiet song of color. When its light is passed through a prism, it separates into a rainbow, streaked with delicate lines, the fingerprints of elements within. Hydrogen, helium, oxygen, and carbon each leave their marks, small absences in the light that tell great truths. By reading these spectral lines, astronomers can learn a star's temperature, its motion, its age, and even what it's made of. Each pattern is unique, like a melody composed in fire. Through these spectral signatures, the cosmos speaks in code, and we learn to translate its music into meaning. The result is a language of light, one that connects us to suns far beyond our reach. And when all those voices are plotted together, a grand map of star life unfolds. Fact 24. The Hertzsprung-Russell diagram. The story of stars can be told on a single, beautiful graph, the Hertzsprung-Russell diagram. Across its axis, temperature meets brightness, revealing the secret order of stellar existence. Every point of light finds its place. Small red dwarfs, golden suns, and vast blue giants, each forming a graceful curve across the chart. It's not just data. It's a portrait of evolution. The biggest stars occupy the high, hot corner, burning fiercely for only a brief moment in cosmic time. The smallest linger below, glowing steadily for billions of years. This simple diagram holds the quiet rhythm of birth, life, and fading light, a celestial symphony drawn in numbers. And from those patterns, astronomers learn to see the stars not as dots, but as living stories written in heat and time. Fact 25. Angular diameter. To measure a star's size, scientists must first learn to read its apparent width, its angular diameter. But even the largest stars appear as pinpoints in our sky. Their vast bodies are separated from us by distances so immense that a whole supergiant fits easily, within a fraction of a second of arc, smaller than the smallest shadow. With delicate instruments, astronomers measure how much a star's light spreads or dims, using geometry and light curves to infer its true scale. Each calculation feels like tracing the outline of a distant flame, never directly touched, but deeply known. It's an art of inference, of quiet reasoning through brilliance. And when single eyes can't see far enough, many must work together to see as one. Fact 26. Interferometry's precision. Interferometry is the practice of weaving many telescopes into one vision. By combining the light gathered from several observatories, astronomers can achieve clarity beyond the limits of any single mirror. The waves of light overlap and interfere, creating a pattern that reveals detail far finer than any single image could show. Through this technique, the surfaces of stars like Betelgeuse and Antares have been mapped, not as points, but as worlds of shifting light and color. We can see their storms, their spots, their quiet flares of dust and gas. It's a triumph of collaboration, a constellation of instruments working in harmony, listening together to the same song of starlight. And yet, even with all this precision, the cosmos still keeps its gentle secrets. Fact 27. The challenge of distance. The greatest difficulty in studying giant stars is not their light, but their remoteness. Dust clouds dim them. Time and motion distort their stories. Many lie hidden in crowded clusters, or behind veils of gas that blur their boundaries. Measuring them is like gazing through water. The image wavers, but the truth remains beneath. Astronomers use models, parallax, and spectra to guess at the true nature of these elusive giants. Each new discovery reshapes what we thought we knew. Even so, uncertainty is part of the beauty, a soft edge that reminds us the universe is still mysterious. In every observation, there is humility, a quiet acknowledgement that we are learning to see through infinite distance. And from these glimpses, we begin to imagine the fires within. Fact 28. Models of fire. Because the great stars lie far beyond reach, astronomers turn to models, quiet equations that recreate their inner lives. In the language of physics, they describe how heat moves, how atoms fuse, how gravity holds everything together. These are not mere numbers, but sketches of flame and balance. A model of a massive star begins at its core, where hydrogen fuses to helium, releasing torrents of light. Layer by layer, it follows the flow of energy outward, through shells of fire and convection, until it reaches the shining surface we can see. When these models align with the colors and brightness we observe, it feels like hearing the echo of truth from across the void, a whisper of understanding from the heart of a distant sun. And sometimes, that whisper hints at another hidden presence nearby. Fact 29. Unseen companions. Many of the largest stars are not alone. They travel in pairs or trios, bound together by gravity's quiet thread. Often, their light merges so closely that we see only one, but careful observation reveals the signs: a wobble in position, a rhythm in brightness, a heartbeat of orbit. In these binary systems, one star may feed from another, pulling streams of gas that spiral like silver ribbons between them. Sometimes both are giants, each shaping the other's fate. Other times, one has already died, leaving behind a remnant, a neutron star or black hole, circling its still living companion. To the eye, it is a single star. To the universe, it is a duet, two voices bound in eternal motion. And together, they teach us about balance, distance, and the poetry of scale. Fact 30. The poetry of scale. To understand how vast these stars are, imagine this. If our sun were the size of a small bead, a red supergiant like Betelgeuse would be a sphere as wide as a mountain. A blue hypergiant might stretch across continents, yet all of them float as weightless points in the night sky, their enormity hidden by perspective. Scale in the cosmos humbles us. We stand beneath it, tiny and aware, tracing patterns in light older than life itself. The numbers are almost too large to hold, but the feeling they create is simple, quiet wonder. In that sense, scale is not a measurement, but a meditation. One that reminds us how beautiful it is to be small beneath something infinite. And from that stillness, we begin to explore how these giants live and breathe. Fact 31. The short lives of the mighty. The larger a star is, the faster it lives. A giant burns through its fuel with desperate brilliance, shining 1,000,000 times brighter than the sun, but living only a fraction as long. Where small stars endure for tens of billions of years, the biggest may fade after only a few million. It's a paradox of nature. The stronger the fire, the shorter its time to burn. These colossal suns blaze not in moderation, but in rapture. Every heartbeat of fusion, an act of exuberance. Their energy floods entire nebulae, shaping the birth of smaller stars nearby. They live like cosmic fireworks, brief, magnificent, unforgettable. And at the center of it all lies their endless hunger, a craving for hydrogen that defines their very being. Fact 32. Hydrogen's hunger. Every star begins its life as a furnace of hydrogen. In its core, this simplest element becomes something greater, pressed by gravity into fusion, where 4 atoms combine to form one of helium. In that transformation, a tiny bit of mass becomes pure energy, radiating outward as light. For the largest stars, this process happens at a frantic pace. Their cores are so hot and dense that hydrogen vanishes quickly, feeding the insatiable engine of fusion. When the supply dwindles, the core contracts and heats again, seeking a new fuel to burn: helium, carbon, oxygen, and beyond. This constant striving, this hunger for energy, is what drives a star's evolution. It is the quiet heartbeat of creation itself, steady, relentless, and awe-inspiring. And as that hunger deepens, the star begins to form layers within itself, like an onion made of fire. Fact 33. Layers of fire. Inside a massive star, fusion doesn't happen in just one place. It occurs in shells, stacked like rings of molten light. At the center, helium fuses into carbon. Above it, hydrogen continues to burn. And around those layers, new reactions begin, building heavier elements as time goes on. Each layer glows at a different temperature, creating subtle patterns of rhythm and motion. The star becomes a cathedral of fusion, vast, intricate, and alive. Through these layers, matter is reborn over and over, until the core can no longer bear its own weight. Yet even as pressure builds, there's a fragile harmony, the push and pull that keeps the star from collapsing too soon. And in that balance lies the next part of the story. Fact 34. Balancing light and gravity. Every star exists because of a delicate truce. Gravity pulls inward, drawing everything toward the core, while the energy of fusion pushes outward, resisting collapse. For most of its life, a star lives at the boundary between these two forces, not falling, not flying apart, but held in luminous balance. In the most massive stars, this equilibrium is precarious. Their brightness presses fiercely against gravity's pull, and any small change can tip the scales. Yet somehow they persist, shining with serene composure, their light a constant act of balance. This is the secret of starlight. Every gleam in the night sky is a harmony between creation and collapse. And sometimes, that harmony takes the form of rhythm, a pulse that echoes through space. Fact 35. Pulsations and rhythms. Some stars breathe. They expand and contract in cycles, swelling as heat rises within them, then cooling and shrinking as that energy escapes. These slow, steady pulses can last days, months, or even years. A heartbeat of light that can be seen across the cosmos. In red giants, these pulsations send waves of gas into space, creating thin shells of drifting matter. Each expansion, each contraction, is gentle, like a sigh repeated over centuries. Astronomers measure these rhythms, translating brightness into time and time into distance. To watch a star pulse is to witness the tempo of the universe itself, vast, patient, and calm. And some of these pulsations become so regular, so musical, that we call them variable stars. Fact 36. Variable stars. Variable stars are the storytellers of the sky. Their changing light reveals the secret mechanics of their hearts. Some brighten and fade because of inner pulsations. Others because they share light with a companion that eclipses them in orbit. Among them are the Cepheids, cosmic lighthouses whose steady patterns of brightness allow us to measure the scale of galaxies. Their flicker is precise, their rhythm constant, like the ticking of a celestial clock. For astronomers, these stars are both instruments and poems, tools for measuring the universe, and reminders that even constancy can have gentle variation. In their dimming and brightening, we see that change need not be chaos. Sometimes it is simply the breath of light. And within that breath, magnetism begins to stir. Fact 37. Magnetic majesty. Inside every star, electricity and motion weave invisible fields of force, vast magnetisms that shape the flow of gas and light. In the largest stars, these fields can span millions of kilometers, strong enough to twist the paths of charged particles and sculpt the surfaces themselves. Magnetism gives rise to spots of brightness and darkness, regions where energy bursts outward in waves. It drives stellar winds, guides radiation, and sculpts entire nebulae. For giant stars, magnetic loops can arch into space like ethereal bridges of fire. These unseen fields hold quiet majesty, reminders that even the most luminous things are ruled by the invisible. And when these stars spin, the dance of magnetism grows even more complex, a whirl of balance and brilliance. Fact 38. Rotation's secret power. A star's rotation is more than motion. It is its hidden heartbeat. The great giants spin swiftly in their youth, stirring their interiors like cosmic cauldrons. This rotation mixes their elements, spreading the products of fusion throughout their bodies and giving them longer, more complex lives. As time passes, stellar winds carry away angular momentum, slowing the spin, a quiet aging process written in the fabric of space. For some stars, rapid rotation pushes them to the brink of instability, flattening their shapes and fueling immense jets of matter. In these spinning spheres of fire, the rhythm of motion and the rhythm of fusion intertwine, one shaping the other in a timeless waltz. And when they find partners in the sky, that waltz becomes a duet written in light. Fact 39. Companions in orbit. Many massive stars are not solitary. They live in pairs, circling one another in slow, luminous spirals. Some share matter between them, rivers of plasma flowing across the space that divides them. Others simply dance at a respectful distance, bound forever by gravity's steady pull. In close binaries, one star can feed from its companion, stripping gas and altering both their fates. When one collapses or explodes, the other bears the mark of that cosmic intimacy. Its orbit changed, its surface enriched with new elements. To the naked eye, they appear as one point of light. But through the telescope's patient gaze, their shared rhythm becomes clear. A quiet story of companionship written across eternity. And in the hearts of such companions, new elements begin to bloom. The metals of the universe, forged in their fire. Fact 40. Metal in the fire. Inside the blazing cores of the biggest stars, new elements are born. Hydrogen becomes helium. Helium becomes carbon, then oxygen, neon, silicon, the slow ascent toward iron. Each transformation releases energy, a steady heartbeat that keeps the star alive. In the language of astronomy, everything heavier than helium is called metal, and it is in these fires that all such metals are forged. Every breath of iron in our blood, every flake of calcium in our bones, once belonged to a star like this. Created in its furnace, scattered in its death. The elements are the quiet inheritance of light, passed from one generation of stars to the next. Within that fire, the cycle of giving begins, and with it comes the breath that shapes galaxies. Fact 41. The breath of a star. Massive stars do not merely shine, they exhale. Their heat and radiation drive outflows of gas called stellar winds, carrying away matter at millions of kilometers per hour. These winds are not chaotic storms, but graceful, continuous streams of light and plasma. Over time, these currents form vast bubbles around the star, glowing faintly where they meet the interstellar medium. The material shed by these winds becomes part of the cosmic sea, drifting, cooling, and waiting to be reborn as new stars, planets, or clouds of dust. When we gaze at the night sky, We are watching the gentle breathing of creation, and as that breath slows, it leaves behind delicate ashes, the dust of flame. Fact 42. Dust from flame. From the hot outflows of dying giants comes dust, fine grains of carbon, silicon, and iron that cool as they drift away. To the eye, they seem like darkness, but in truth, they are seeds. Tiny solids that will one day form planets, comets, and perhaps even living worlds. Infrared telescopes can see this dust glowing softly, warmed by the light of its parent star. It floats in endless silence, collecting in veils and spirals, shaping the glowing contours of nebulae. In the gentle decay of a giant, the universe creates again. Every loss becomes foundation, every ember becomes promise, and from that promise, new beauty rises, nebulae born from a star's quiet goodbye. Fact 43. Nebulae of farewell. When a massive star nears the end of its life, it releases vast clouds of gas and dust, shimmering shells that drift outward into space. These are nebulae of farewell, glowing reminders of endings that lead to beginnings. Each one is a memory of a star's last breaths, illuminated by the light it once gave. Their shapes are diverse and dreamlike, veils, bubbles, and rings that twist through the void like celestial silk. What we see as beauty is actually physics in motion. Atoms of hydrogen and oxygen colliding, recombining, and glowing as they cool. These nebulae are both grave and garden, the resting place of a star and the cradle of stars yet to come. And among them shines one of the most hauntingly beautiful, a relic of fire called the homunculus. Fact 44. The Homunculus Nebula. In the constellation of Carina lies a nebula like no other, the homunculus, the ghostly shroud of Eta Carinae's great eruption. Two lobes of glowing gas stretch outward, shaped by a blast so fierce it outshone nearly every star in the sky. Each lobe is filled with dust and molecules, still expanding, still carrying the echo of that violent light. Seen through telescopes, it appears golden and blue, like two opposing wings surrounding a hidden core. Though born of destruction, it drifts with solemn grace, quiet now, but radiant. Astronomers study it to understand how stars shed their skins, how energy moves through chaos toward calm. The homunculus is a monument to transformation, the peace that follows a storm. And farther away, another nebula whispers of gentler origins lit by the reflection of starlight. Fact 45. The Pleiades Mist. The Pleiades, also known as the Seven Sisters, sparkle in the shoulder of Taurus. Around them, faint blue mist swirls. A reflection nebula, not born from the stars themselves, but illuminated by their presence. The dust here is ancient, drifting across their path, catching their light like dew in morning air. Through this mist, the stars shimmer softly, their light scattered into delicate shades of blue. The cluster is young, barely 100 million years old, its suns still wrapped in the gauze of their birth. The Pleiades remind us that not all beauty comes from violence. Sometimes it is simply the meeting of light and silence. And beyond those quiet veils, waves of energy ripple outward, invisible shock fronts marking the edge of stellar breath. Fact 46. Shock fronts in space. When a star's wind races outward, it eventually meets the slower gases that surround it. The collision forms a thin boundary, a shock front, where energy suddenly compresses and the atoms begin to glow. These regions, though invisible to our eyes, can stretch for light years, marking the edges of stellar influence. Astronomers see them through radio and X-ray telescopes as arcs and filaments of light threading through the darkness. They are the fingerprints of movement, the quiet record of a star's long conversation with the void. Each shock front tells a story of expansion, of pressure, of change. It's where motion becomes memory, frozen into the fabric of space. And when a star moves swiftly through the galaxy, those ripples take on a graceful, curved form, the bow of a celestial ship cutting through a sea of dust. Fact 47. Bow shocks. Imagine a boat gliding through calm water. The waves it makes curve outward in soft arcs ahead of it. A similar shape forms when a speeding star plows through the interstellar medium. Gas and dust pile up before it, creating a luminous crescent called a bow shock. These glowing arcs reveal where motion meets resistance. They show us not just where a star is, but how it moves, tracing invisible paths across the galaxy. Some bow shocks shimmer faintly in infrared light, illuminated by the star's breath. Others blaze fiercely, marking the routes of runaway suns traveling hundreds of kilometers each second. Each bow shock is a silent sculpture of motion, a glowing wake in the cosmic ocean. And beyond these waves, the material a star sheds becomes nourishment for the universe itself. Fact 48. Mass loss and renewal. Every massive star, through winds and eruptions, gives part of itself back to the cosmos. The hydrogen and helium it expels, the carbon and oxygen it forms, all of it drifts into the interstellar medium, mixing like gentle ink in water. This released matter cools, gathers, and one day condenses again into new stars, new worlds, and new beginnings. In this way, the death of one light becomes the birth of countless others. Mass loss is not an ending, but a gesture of generosity, the universe recycling itself through the language of starlight. And in that swirling dust, warmth lingers, light echoing softly from what once was. Fact 49. Infrared revelations. When the light of a dying giant dims beyond the range of our eyes, it continues to glow in warmth. Infrared telescopes, sensitive to this gentle heat, reveal what visible light cannot. The veiled hearts of stars hidden behind clouds of dust. Through them, we can see the soft embers of red supergiants, the halos of gas expanding outward, and the faint currents of wind that shape the nebulae around them. Infrared light travels through what darkness conceals. It shows us that endings are not silent, but quietly radiant. From these wavelengths, astronomers reconstruct the hidden life of a star, its breathing patterns, its outflows, its slow surrender to the cold. In that warmth lies a promise that nothing truly disappears. It only changes how it shines. And when light meets dust, the universe remembers, for even echoes can be luminous. Fact 50. Echoes in the dust. When a giant star releases a sudden burst of light, a flare, an eruption, or a final explosion, the glow travels outward, striking layers of dust and gas. These clouds scatter the light back toward us, delayed by distance, forming what astronomers call light echoes. To watch a light echo is to glimpse time itself unfolding in ripples. Each reflection is a moment replayed, light from long ago finding new surfaces to dance upon. Through these echoes, we can study a star's final moments long after they've passed, each shimmer a soft remembrance in the dark. The cosmos holds its memories gently, storing them in dust until they are ready to shine again. And when the echoes fade, silence deepens, the quiet before the end. Fact 51. The end comes swiftly. For a massive star, the end arrives in sudden, breathtaking collapse. After millions of years of steady fusion, the core can no longer hold itself against gravity. In a final, Instant, it gives way. A cascade of inward motion that ends in an explosion of unimaginable energy. In seconds, the light outshines entire galaxies. Layers are hurled into space. New elements are born. But within the core, silence reigns. The birth of something dense, new, and strange. A supernova is not death, but transformation. A heartbeat so loud the universe must pause to listen. And from that brilliance, the story continues toward iron and the final barrier of fusion. Fact 52. Iron, the final stone. At the very center of a massive star, fusion builds heavier and heavier elements until it reaches iron. Here, the chain of creation comes to a stop. Unlike lighter elements, fusing iron requires more energy than it gives, and so the fires that sustain the star begin to falter. The core grows heavy and inert, gathering mass it can no longer balance. Around it, the outer shells still burn, unaware that their foundation is dying. For a brief time, the star glows in quiet denial, a luminous monument to its own approaching end. Iron is the cosmic threshold, the quiet stone upon which every giant must rest. Beyond it lies collapse, gravity reclaiming what light once held. And when that balance breaks, the fall is instant and absolute. Fact 53. Collapse into darkness. When fusion stops, gravity wins. The core of the star, once held up by pressure, implodes in a fraction of a second. Atoms are crushed together. Protons and electrons fuse into neutrons. The material of worlds collapses into a single sphere, no larger than a city, yet heavier than the sun itself. The fall sends shockwaves through the surrounding layers, a roar of energy rebounding from the center. In that moment, the star's heart turns to darkness, dense, silent, and beyond comprehension. It's not destruction, but transformation. The surrender of form to gravity's embrace. The star that once gave light now becomes a well where light cannot stay. And then, from that collapse, comes the universe's most radiant farewell, the supernova moment. Fact 54. The supernova moment. A supernova is the final breath of a dying giant. An explosion so vast, it outshines entire galaxies for days or weeks. In the span of a heartbeat, the collapsing core rebounds, and energy rushes outward in a storm of light and particles. The shockwave tears through the star's layers, scattering its elements into space. Gold, silver, iron, and carbon flung like sparks from a cosmic forge. The light travels across time, carrying the story of that ending to every world that watches. To us, it appears as sudden brightness in the night sky. To the universe, it is renewal, a fiery bloom in the eternal garden of creation. And after the light fades, faint whispers remain, the ghostly neutrino winds that carry the last echo of the star's soul. Fact 55. Neutrino winds. In the instant of a supernova, the star releases a flood of ghostly particles called neutrinos, silent travelers that stream through everything, even entire planets, without slowing. They carry away most of the explosion's energy, unseen yet essential. These neutrino winds are faster than thought, reaching across space before the light itself emerges. They rush outward, cooling the core and setting the shockwave free. Without them, the star's death would remain trapped, its energy unable to escape. Billions pass through us every second, reminders that we are bathed in the relic breath of dying suns. They whisper of endings that make room for beginnings, and as their invisible tide drifts outward, new matter begins to form. The art of rebirth, written in ashes and gold. Fact 56. The art of rebirth. Out of the chaos of a supernova comes order, a cosmic rebirth. The explosion scatters elements forged in the heart of the giant, mixing them into the interstellar medium. Hydrogen and helium meet carbon and oxygen, seeding future generations of stars and worlds. From this debris, new nebulae take shape. Clouds cool, condense, and begin again the slow process of formation. The remnants of one life become the foundations of countless others. A quiet continuity that threads the universe together. This is the poetry of existence. Nothing wasted, nothing lost. The star's death is a gesture of generosity, gifting the cosmos its building blocks. And sometimes, that gift comes not as a simple supernova, but as something even grander, a hypernova, the most powerful explosion of all. Fact 57, hypernovae. A hypernova is a supernova magnified, the death of a star so massive and energetic that its collapse tears open space itself. In these rare events, a core implodes to form a black hole, while jets of material blast outward at nearly the speed of light. The brightness rivals that of entire galaxies. The energy reshapes its surroundings for light years. Hypernovae are among the universe's most extreme symphonies, chaotic yet structured, violent yet creative. For all their power, they last only moments, leaving behind darkness where brilliance once burned. Yet from that darkness comes new chemistry, new beginnings, and sometimes the birth of mysterious bursts of radiation. And those bursts, fleeting, fierce, and ancient, are the next quiet mystery the universe reveals. Fact 58. Gamma-ray bursts. In the deepest reaches of the cosmos, there are flashes of light so intense they outshine entire galaxies. Yet they last only moments. These are gamma-ray bursts, born when the core of a massive star collapses into a black hole, or when two neutron stars merge in a final embrace. They send narrow beams of radiation across billions of light years, a focused whisper of unimaginable energy. For a brief instant, they transform the universe into brilliance, invisible to human eyes, but captured by the instruments that listen beyond color. Though they begin in violence, their legacy is creation. The jets scatter heavy elements across space, seeding galaxies with gold and platinum. In the wake of such a flash, the universe exhales, and the remnants of the star begin to glow. Fact 59. Supernova remnants. What remains after the explosion is a ghost, a cloud of expanding gas and dust, glowing faintly in hues of blue, green, and crimson. These supernova remnants are among the most beautiful structures in the night sky. The Crab Nebula, the Veil, and Cassiopeia A all carry the memory of brilliant endings. Each filament is the trace of a wave of light that once raced through the star's body. The colors reveal the chemistry of creation. Oxygen shining teal, hydrogen blushing red, sulfur glowing gold. Astronomers study these remnants to understand how energy moves through time, how chaos cools into order. They are fossils of light, still expanding, still whispering the tale of their birth. And when their glow finally fades, space falls into the softest hush, the calm after the light. Fact 60. The calm after the light. When a supernova's final embers dim, what remains is silence. The nebula drifts outward, thinning into the background of the galaxy. The shock waves slow, the heat disperses, and the airless void grows still again. Yet even in that stillness, creation continues. From the leftover gases, new molecules form, the precursors of clouds, of worlds, of life. The quiet after a star's death is not emptiness. It is potential, gathering its breath. The universe, in its patience, teaches us that endings are pauses, not finales. light fades, only to return in another form, somewhere new, someone else. And within that silence, the remnants of giants condense, the birth of something dense, mysterious, and enduring. Fact 61. Neutron stars. When a massive star dies and its core collapses inward, sometimes it stops just short of becoming a black hole. The result is a neutron star, a sphere no wider than a city, yet heavier than the sun. Inside it, gravity squeezes matter so tightly that protons and electrons merge into neutrons, creating a substance denser than anything else in the universe. A teaspoon of this material would weigh billions of tons. Its surface, though solid, quivers with magnetic storms and the faint heat of decay. Yet from that pressure, something astonishing happens. The star's rotation speeds up, spinning many times each second. These tiny remnants are the universe's most compact memorials, reminders that even endings can be condensed into brilliance. And when that spin aligns with magnetism, the result becomes a cosmic heartbeat, the pulse of eternity. Fact 62. Pulsars and their beats. Some neutron stars send beams of radiation from their magnetic poles, narrow, piercing lights that sweep across the cosmos as the star spins. To distant observers, these flashes appear rhythmic, pulsing in perfect time. Thus, we call them pulsars, the lighthouses of the universe. Each pulse is a reminder of precision amid chaos, a rotation so regular that it rivals our best clocks. Astronomers have used pulsars to measure gravity, space-time, and even the movement of planets. Their sound, if we could hear it, would be a steady tick, the universe keeping time with itself. They are proof that even in collapse, there can be structure. Even in silence, rhythm. And when gravity deepens further still, even light cannot escape, giving birth to something darker and yet more profound. Fact 63. Black holes from giants. For the heaviest stars, the collapse does not stop. Gravity overwhelms every force that resists it, pulling all matter into a single, infinitely dense point, a black hole. Around it, space folds inward, and time itself slows. The edge of this abyss is called the event horizon, the line beyond which nothing can return. Though invisible, black holes reveal themselves through what they touch. Gas spirals toward them, heating and glowing before vanishing. Their presence bends starlight, distorts time, and hums with quiet gravity. A black hole is not an ending, but a transformation, a door through which matter becomes mystery. And at its edge, the last traces of starlight shimmer, caught between existence and eternity. Fact 64. Event horizons. At the boundary of a black hole lies the event horizon, the ultimate horizon of perception. It is not a surface, but a threshold, marking the place where escape becomes impossible. Beyond it, space folds so steeply inward that even light, the fastest thing in existence, cannot climb back out. To watch matter approach the event horizon is to see time slow, almost to stillness. From far away, the star's final light seems to freeze at the edge, fading gently into black. Yet from within, everything continues, unseen, unknowable, and perfectly silent. An event horizon is a curtain drawn over mystery. What lies beyond remains hidden, yet it is not destruction, only a different form of being. And just outside that darkness, light still swirls in luminous surrender. Fact 65. Accretion, disks around black holes and neutron stars. Matter often forms graceful spirals called accretion disks. These glowing rings are made of gas and dust pulled from nearby stars or drifting clouds. As the material falls inward, Friction heats it to astonishing temperatures, causing it to radiate brilliantly, sometimes brighter than the entire galaxy that surrounds it. Seen through telescopes, accretion disks appear as halos of color, circling the blackness like fire around a void. They are dynamic, turbulent, and yet astonishingly beautiful. A perfect paradox of chaos and harmony. The inner edge spins near the speed of light, creating gravitational ripples that echo through space. These are not just disks of matter, but the turning pages of the universe's most secret story. And when those ripples reach us, we hear them not in sound, but in waves that move the very fabric of reality. Fact 66. Gravitational waves. When massive objects like neutron stars or black holes collide, they send tremors through space-time itself. Gravitational waves, gentle undulations that stretch and compress the cosmos as they travel. Detected only recently, these waves confirm that even emptiness can carry motion. Each ripple is a faint echo of titanic events, mergers of giants, collapses of suns, the choreography of gravity at its most powerful. Instruments on Earth listen for these signals, translating them into whispers of cosmic history. It is humbling to know that every vibration passes through us unnoticed, a lullaby of the universe itself, soft and eternal. And sometimes, those waves come from two ancient companions, drawn back together after eons apart. Fact 67. Binary collisions. Sometimes, the universe brings its remnants back together. Two neutron stars, born from separate supernovae, can orbit each other for billions of years before slowly spiraling inward. When they finally meet, the collision releases more energy than a million suns combined. The impact sends waves through space-time, tremors that reach across the cosmos, detectable as faint whispers in the instruments of Earth. The light from these mergers glows in soft, fading hues of blue and gold. In those fleeting seconds, entire worlds' worth of heavy elements are created. The universe shakes, then settles, leaving behind a single, quiet remnant. And within that brief burst of brilliance, something precious is born: gold, platinum, and the rarest atoms of all. Fact 68. The gold makers. Every piece of gold that gleams on Earth was once part of a star's death. In the mergers of neutron stars and the explosions of hypernovae, conditions grow extreme enough to forge the heaviest elements: gold, silver, uranium, and more. These metals are born in seconds, scattered outward in glowing waves. They cool as they drift, joining the dust that will one day form planets, oceans, and living things. In that sense, the jewelry we wear and the veins of metal deep in our planet are relics of cosmic violence transformed into beauty. Each glint of gold is a piece of history, starlight made solid, a memory of creation carried quietly through time. And when that dust settles, it doesn't only shine, it builds. It becomes the raw material of worlds. Fact 69. Supernova dust. The dust from dying giants is the substance of everything. Each fine grain contains the signature of its parent star: carbon from red giants, silicon from supernovae, iron from collapsing cores. Over millions of years, this dust drifts through space, gathering in clouds that birth new suns and planets. Some of it found its way here, long before Earth formed. The atoms in our bones, the air we breathe, the stones beneath our feet, all were once suspended in that quiet, drifting haze. Supernova dust is the universe's way of recycling itself, of breathing life into the void, and through every shining atom, the legacy of those ancient fires endures, the eternal gift of the stars. Fact 70. The legacy of fire. Every atom in the universe bears the mark of a star. The oxygen in the air, the iron in your blood, the calcium in your bones. All were forged in stellar furnaces and scattered by explosions long forgotten. Each one carries the signature of its origin, the temperature it knew, the pressure it endured, the distance it traveled through the cold between worlds. When we look to the sky, we see not just stars, but our own reflection, matter remembering its birthplace. The legacy of fire is written everywhere, in oceans, in clouds, in the warmth of sunlight on skin. To exist is to glow faintly with borrowed starlight, and that light, multiplied through generations, builds the quiet history of the cosmos itself. Fact 71. Stellar populations. Astronomers divide the stars into families, called populations, to trace their ancestry. Population I stars, like our Sun, are young and rich in heavy elements, born from the ashes of older generations. Population II stars are ancient, poor in metals, but pure in their simplicity. And beyond them, in theory, lie Population III, the first lights that ever burned, now long extinct. Each population carries a record of its time, its chemistry, its color, its place in galactic evolution. In studying them, we read the autobiography of the universe, a story told not in words, but in spectra and light. The stars are archivists, keeping perfect memories of every age that came before. And in their memories, the metals they carry whisper the history of creation itself. Fact 72. Metallicity and memory. A star's metallicity, the measure of how many heavy elements it contains, is its age written in light. Younger stars glow with richer compositions, infused with the gold, carbon, and oxygen left behind by their ancestors. Older ones shine with simpler purity, born in a time before such complexity existed. By reading these signatures, astronomers can date galaxies, trace migrations, and see how the universe matured from simplicity into splendor. The stars, in their chemistry, preserve the collective memory of cosmic time. Metallicity is the fingerprint of evolution, proof that every spark builds upon another. And through those layers of memory, stars have shaped not just galaxies, but the spirals that cradle them all. Fact 73. Galactic architects. Massive stars are not just residents of galaxies. They are their builders. Their radiation sculpts the clouds around them. Their winds sweep vast cavities through interstellar gas, and their depths enrich space with metals that give color and structure to everything that follows. A handful of giants can change the landscape of an entire spiral arm, triggering new waves of star formation. Their light pushes against dust, carving glowing corridors where new suns are born. The Milky Way, serene and silver from afar, is shaped by these restless architects within. In every beam of starlight, there is quiet creation, order born from brilliance, structure born from fire. And through this endless shaping, galaxies maintain the fragile balance between birth and stillness. Fact 74. Feedback and balance. The largest stars give as much as they take. Their energy, the radiation, the winds, the shock waves, is a form of feedback that regulates how many new stars can form. Without it, galaxies would collapse under their own weight, birthing too many suns too quickly. Instead, the feedback from giants heats and disperses the gas, slowing creation to a sustainable rhythm. It's as if the universe breathes in cycles: expansion and rest, ignition and calm. This balance ensures that galaxies live not in chaos, but in harmony. In their brief lives, these stars act as guardians of equilibrium, Their ferocity sustains the long peace of the cosmos, and sometimes they work together, gathering in glittering clusters that hold hundreds of their kind. Fact 75. Clusters of giants. Within the swirling arms of galaxies lie stellar clusters, communities of massive stars born together from a single cloud. These clusters, dense and radiant, shine like islands of blue-white fire. Their light reveals the youngest and most energetic phases of stellar life. In places like Westerlund 1 or R136, hundreds of giants coexist, their winds colliding, their radiation intertwining. The cluster glows with shared vitality, a brief, brilliant age that lasts only a few million years before dispersing. To look at such a cluster is to see the cosmos at its most alive. Creation in chorus, unity in light. And among these families of fire, one nebula stands out as the grandest cradle of them all. Fact 76. The Tarantula Nebula. In the southern skies of the large Magellanic Cloud lies a wonder of creation, the Tarantula Nebula. It is the most active star-forming region we can see beyond our galaxy, a sprawling cloud of hydrogen and light spanning nearly 1,000 light-years. Within its glowing folds are some of the most massive stars ever known, including R136A1, whose power outshines millions of suns. The nebula hums with energy, its filaments woven by radiation and wind. Every shimmer marks a cradle of new life, stars forming from the ashes of others long gone. It is a cosmic nursery, vast and alive, a reminder that creation and destruction are always intertwined. And sometimes, when many such regions awaken together, a whole galaxy bursts into brightness. Fact 77. Starburst galaxies. A starburst galaxy is one caught in a fever of creation, a place where stars are forming 1,000 times faster than usual. Collisions between galaxies often trigger these bursts, compressing gas clouds and igniting new generations of suns in brilliant waves. From afar, these galaxies glow blue and white, their light young and fierce. The airless silence of space hides their true intensity. Billions of newborn stars shining at once, each wrapped in veils of dust. But this frenzy cannot last. After only a few million years, the fuel runs low, and the galaxy quiets again, resting in the afterglow of its labor. Even the universe, it seems, understands the need for balance, for the stillness that follows creation. And in that stillness, everything begins to recycle once more. Fact 78. Cosmic recycling. Nothing in the cosmos is wasted. The gas exhaled by dying giants, the dust left by collisions, even the faint ashes of ancient explosions, all return to the interstellar sea. Over eons, this material drifts, mixes, and gathers again, drawn by gravity into new clouds. From this endless cycle arise new stars, new planets, and perhaps new forms of life. Each generation carries the chemistry of the last, enriched and transformed. Cosmic recycling is the universe breathing, in and out, endlessly, peacefully. Every sunrise on every world is part of that rhythm. And at the heart of it all, galaxies spin in quiet grace, guided by invisible arms of gravity. Fact 79. Spirals of light. When we look at the night sky through a telescope, spiral galaxies appear like frozen whirlpools of starlight. Their arms sweep outward in graceful arcs, filled with young, luminous stars that sparkle blue and white. These arms are not solid structures, but waves of density, where clouds of gas compress and give birth to new suns before drifting onward again. Our Milky Way is one of these grand spirals, vast, serene, and alive with motion. Every arm carries the memory of generations of stars, like ripples upon a cosmic sea. The pattern is timeless, rotation, renewal, and rest. From afar, it looks like stillness. Up close, it is an endless dance. And as those stars breathe and burn, their light stirs the space between them. Gentle winds across the galaxy's face. Fact 80. Galactic winds. Just as stars exhale through their stellar winds, galaxies breathe on a grander scale. When clusters of supernovae ignite within spiral arms, they release colossal currents of gas that sweep upward and outward. Galactic winds. These invisible flows carry metals and dust far beyond the galaxy's plane, enriching the vast intergalactic medium. Sometimes, these winds stretch for tens of thousands of light years, glowing faintly where they collide with cosmic dust. They are soft but powerful, sculpting the galaxy's edges and maintaining its balance. Through these gentle outflows, galaxies shed the heat of their creation. It's a form of cosmic respiration, a sigh that cools the star's fiery work. And beyond those edges, the light grows thin, fading into a quiet halo that holds the galaxy together. Fact 81. The quiet halo. Encircling every galaxy is a faint, nearly invisible halo of dark matter, gas, and old stars. It extends far beyond the shining disk, unseen but immense. This halo is the galaxy's silent guardian, its gravity binding all within, its touch felt but never seen. Within it drift the ghosts of ancient stars, remnants from the earliest ages of formation. Their orbits are slow, serene, timeless. Though we cannot view them directly, their presence reveals itself through the gentle bending of light, a whisper of mass in the dark. The halo is stillness itself, the quiet framework upon which all beauty rests. And within that calm, new stars continue to bloom, like embers rekindling in an infinite night. Fact 82. Galactic collisions. Across the deep tapestry of the cosmos, galaxies are not static islands. They move, drawn by gravity's gentle pull. Sometimes, two of them approach each other, their stars passing harmlessly by, but their gases and dust colliding in waves of new creation. These are galactic collisions, moments when vast structures of light and matter intertwine. From afar, they look like slow-motion dances, unfolding over billions of years. Arms stretch, spiral cores distort, and glowing bridges of stars connect one galaxy to another. Though the scale is unimaginable, the process is peaceful, more of a merging than a clash. In these encounters, the universe paints with gravity, blending starlight into new patterns of beauty. And as they continue to entwine, the skies of both galaxies become shared and radiant. Fact 83. Merging skies. When two galaxies finally meet, their shapes dissolve into one another, a spectacle of flowing stars and glowing dust. The collision compresses gas, igniting waves of star formation. For a brief cosmic moment, the merging galaxies blaze brighter than before, filled with the fever of new life. Astronomers have watched these unions unfold through telescopes, the antennae galaxies curling together in tangled arcs, the whirlpool galaxy embracing its smaller companion in a luminous spiral. Over time, the chaos settles. The stars find new orbits, the clouds disperse, and a single, larger galaxy emerges, smoother, rounder, wiser in its stillness. From turbulence, calm is reborn, proof that even in cosmic upheaval, harmony returns. And from those mergers, a new kind of galaxy takes form. Vast and gentle, glowing like an ember, fading into dusk. Fact 84. The birth of ellipticals. When two large spiral galaxies finally merge, their arms often fade, their disks blend, and what remains is an elliptical galaxy, a smooth, golden sphere of older stars. These galaxies are quieter places, filled with the mature light of suns long past their youth. No longer driven by starbirth or rotation, ellipticals rest in equilibrium, luminous fossils of ancient collisions. Their light is steady, their shape serene. They drift through the universe like glowing lanterns, testaments to the passage of time. In them, the energy of former storms has softened into calm. The fires of creation have cooled into peace. And beyond them, deeper still, lie the filaments that bind the galaxies together, the universe's grandest web. Fact 85. The cosmic web. When we look far enough into the universe, we see that galaxies do not float alone. They gather into vast filaments of light, enormous chains and clusters that stretch across billions of light years. Between them lie immense voids, silent expanses almost empty of matter. Together, this pattern forms the cosmic web, the grand structure of the universe itself. The filaments glow faintly, woven from galaxies and dark matter, each thread humming with quiet motion. It is the skeleton of creation, a network drawn by gravity and time. Within it, energy flows, matter moves, and new galaxies slowly form. To imagine it is to glimpse infinity's design, a lacework of starlight across the void. And at the nodes where these threads meet, the web thickens into great clusters of galaxies. Fact 86. Clusters of galaxies. A galaxy cluster is a family of hundreds, sometimes thousands, of galaxies bound together by gravity. Between them stretches a faint glow of hot gas, heated to millions of degrees, shining in X-rays invisible to human eyes. These clusters are among the most massive objects in the universe, their combined pull shaping the motion of galaxies across vast distances. The galaxies within them orbit like fireflies in a globe of unseen power. Collisions are common here, mergers inevitable. Yet the clusters endure, growing as smaller groups fall into their embrace. Each cluster is a small universe in itself, a community of light surrounded by quiet darkness. And at the heart of many lies something even mightier, a force that draws everything nearby, yet remains unseen. Fact 87. The Great Attractor. In one distant region of the cosmos, galaxies appear to move toward a mysterious gravitational center known as the Great Attractor. Its presence can't be seen directly. It reveals itself only through motion, a subtle drift in the flow of entire clusters. Scientists believe it's a concentration of mass, dark matter, galaxies, and gas forming a hidden supercluster. Its pull reminds us that gravity governs even the largest scales, linking everything in a slow, eternal migration. We, too, are part of that journey, our own Milky Way, drifting quietly toward that unseen heart. And beyond even this, the universe itself continues to expand, carrying all things outward into gentle silence. Fact 88. The expanding universe. The universe is not still. It is stretching. Every distant galaxy drifts away from every other, carried by the expansion of space itself. This is not movement through space, but an increase of space, a quiet swelling of the cosmic fabric. Discovered by Edwin Hubble in the early 20th century, this expansion showed that the universe had a beginning, a moment when everything we see was once compressed into a single, radiant point. Even now, billions of years later, that first momentum continues, carrying galaxies like tiny lights on an endless tide. The expansion is silent, patient, and steady, not an explosion, but a breath that never ends. And with every heartbeat of that growth, the light from the past grows fainter and redder. Fact 89. Redshift and distance. As the universe expands, The light from distant galaxies stretches along with it. Its wavelengths grow longer, sliding from blue to red, a phenomenon called redshift. This soft reddening of cosmic light is a message from the past, a record of how far that light has traveled. Astronomers measure redshift to know how quickly the universe expands, how far the galaxies drift, and how time has changed around them. Each hue tells a story of distance, of journey, of patience. When we observe a galaxy billions of light years away, we do not see it as it is, but as it once was, young and new beneath the early stars. The deeper we look, the further back in time we travel. And beyond all those colors, faint and ancient, lies a whisper from the universe's first dawn. Fact 90. The echo of the beginning. Long after the Big Bang's first light faded, a softer glow remained, the cosmic microwave background. It is the universe's afterimage, a faint wash of warmth that fills all of space. Discovered by chance in 1965, it is the echo of creation itself, stretched by time until it hums in microwaves instead of visible light. This background is astonishingly uniform, yet within its tiny ripples are the seeds of everything: galaxies, stars, and worlds to come. When we tune our instruments to it, we are listening to the universe's oldest lullaby, sung when everything was still light. And from that gentle hum, the story of the first stars begins, the dawn of brilliance in the cosmic night. Fact 91. The first stars. In the quiet centuries after the Big Bang, the universe was dark. There were no stars yet, only vast clouds of hydrogen and helium cooling slowly as space expanded. Then, under the pull of gravity, the first dense knots began to form. Within these knots, pressure rose and heat grew until at last the first fusions began. These were population 3 stars, the pioneers of light. They were enormous, hundreds of times more massive than our sun, and they burned with dazzling intensity. In their short lives, they forged the very first heavy elements, seeding the universe for all that would follow. Though none remain today, their glow lingers in the faint chemistry of younger stars. The universe, once silent and shadowed, had found its first voice. Fact 92. Cosmic dawn. The moment those first stars ignited is called the cosmic dawn. For hundreds of millions of years before, darkness had ruled, filled only with invisible hydrogen gas. But now, light began to spread, not yet steady, but flickering like candles in mist. These early stars gathered into small galaxies, their radiation piercing the fog of the universe. The cosmic night brightened, for the first time, revealing form and structure. Each newborn galaxy was a tiny lantern in the vast void, glowing softly, shaping the future. Cosmic dawn was not a single event, but a gradual awakening, the slow bloom of light across a sleeping cosmos. And as more stars were born, their radiance changed the very nature of space itself. Fact 93. Rionization of light. When the first galaxies blazed into being, their energy transformed the fog that surrounded them. The ultraviolet light they emitted broke apart the neutral hydrogen that once filled the cosmos, creating clear, transparent space for the first time. This process, the rionization of the universe, allowed light to travel freely, turning darkness into visibility. It was as though the cosmos had taken its first deep breath. From that moment onward, galaxies and stars could shine across billions of light years, their light crossing time to reach us today. The rionized universe was awake, open, luminous, infinite. And within its expanding glow, stars began to gather into families, shaping the constellations that one day would watch over distant, dreaming worlds. Fact 94. Constellations of memory. Since the dawn of awareness, humans have looked upward and found meaning in the stars. The scattered points of light became patterns, constellations, drawn across the heavens like stories etched in eternity. Every culture from every corner of Earth traced its own shapes. Hunters, rivers, goddesses, animals, and spirits. Constellations are memory maps, preserving the thoughts of those who came before us. They help travelers navigate oceans, guided farmers through the seasons, and comforted wanderers through the long, cold dark. Even now, when we know the science behind their light, the constellations still feel sacred. They remind us that the sky is both a mirror and a storybook, and among them, some stars have always guided our way, fixed points in the slow drift of time. Fact 95. The guiding stars. Among all the lights above, a few have served as beacons. The North Star, Polaris, has long been a steady companion, marking true north as it glows at the tip of the Little Dipper. For travelers, it was a promise that no matter how far one roamed, there was always a direction home. In the southern sky, the Southern Cross offers its own reassurance, its stars forming a symbol known for centuries to sailors beneath the opposite hemisphere. Around these constants, the heavens wheel in quiet rhythm, every rising and setting written in the same eternal order. Guiding stars teach us patience. They show us that motion and stillness can exist together, that even as everything changes, some lights remain true. And through them, humanity found connection, not just with space, but with itself. Fact 96. Cultural skies. Every civilization has seen the night differently. To the Greeks, Orion was a hunter chasing the Pleiades. To the Maori, those same stars marked the arrival of the new year, Matariki. In China, they became part of the white tiger of the West. To the Navajo, they formed the footprints of sacred beings. Each culture layered meaning upon the same canvas of stars, weaving myth and memory into maps of spirit and time. The sky, unchanged, became a reflection of every story ever told beneath it. Even today, as telescopes reveal galaxies and quasars, that ancient poetry remains. For though the science deepens, the wonder stays the same, quiet, vast, and shared by all who look up. Fact 97. Light that travels forever. Every ray of starlight is a message in motion. Once released, it travels across the vast emptiness for millions or even billions of years, seldom touched, seldom stopped. Some of the light you see tonight began its journey before Earth even formed, before oceans, before life, before memory. Most of it will never find an eye to meet it, but it travels just the same, illuminating dust, reflecting off worlds, whispering through the dark. Light does not hurry. It moves with patient constancy, indifferent to distance and time. When we gaze upward, we are not just looking at the stars. We are touching the past, feeling warmth that has crossed eternity to reach us. And one day, even that light will fade as the stars that birthed it begin to rest. Fact 98. The future of stars. The story of stars is long, but not endless. Over billions of years, the brightest giants will burn out. The smaller suns will cool, and galaxies will slowly dim. The universe will become quieter, its skies filled with the soft glow of red dwarfs and fading embers. Eventually, even those gentle fires will cease. White dwarfs will cool into black dwarfs, invisible remnants of long-vanished suns. The cosmos will grow colder, slower, softer. Yet this too is beauty, a long exhale after endless creation. The stars have always been the universe's heartbeat, And even when that rhythm slows, its echo will remain. And as light recedes, the dark itself becomes the final keeper of memory. Fact Nasenai 9. The slow, fading of the cosmos. Far in the future, when time stretches beyond reckoning, the universe will be vast and silent. The last stars will flicker out, leaving behind only the faint radiation of what once was. A dim afterglow fading gently into forever. But this is not sadness. It is the quiet fulfillment of everything that came before. The stars will have built galaxies, worlds, and life. Their light will have told stories, warmed oceans, and shaped minds capable of wonder. The fading cosmos will be peaceful, a soft dusk over eternity. And within that calm, every atom of every being will still carry the memory of starlight, the universe dreaming of itself. Fact 100. The eternal glow. Even in the farthest reaches of time, when the last stars have gone dark, the universe will not be truly empty. A faint warmth will remain. The lingering radiation of ancient light, stretched thin but never gone. Every particle, every fragment of matter will still hum with memory. In that endless dusk, galaxies will have drifted apart and silence will reign. Yet within that silence lies the same promise that has always existed, the persistence of beauty, the echo of light, the continuation of all that was. We too are part of that glow. Small, brief sparks of consciousness formed from the very atoms of those mighty stars. Their light lives through us, in our breath, our thoughts, our gaze upon the night. So when you look up, know that you are not apart from the cosmos. You are its remembering, its dream, its gentle light that never truly fades. And as our journey among the stars comes to a quiet end, I hope you found a bit of calm in their ancient glow, a sense of peace in the endless rhythm of light and shadow. If you enjoyed drifting through these sleepy facts, don't forget to like this video, subscribe, and share which corner of the cosmos you'd love to dream through next. When you're ready to keep exploring, tap the end screen to travel to the next sleepy astronaut story, and let your curiosity guide you softly among the stars once more. For now, breathe deeply. Let the starlight fade to a soft shimmer behind your eyelids, and rest in the quiet knowing that the universe is vast, gentle, and full of light. Sweet dreams, and see you among the stars.